This is Screencast AP Chemistry 3.10, Balancing Redox Reactions by the Half Reaction Method. Of all the topics covered in AP Chemistry, this is perhaps the most lengthy and tedious. It requires good accounting skills to keep track of everything. One error and you are screwed and have to start over. So, what's this all about? Many redox reactions, when described, become nearly impossible to balance by inspection. You'll just go around in circles forever. That being the case, somebody came up with a stepwise procedure that works. After all, we know the formal charges, that is the oxidation states on everything, so you should be able to use that to balance things out. And so I've come up with a little mnemonic to help you do it. Why are we doing this? It's too complex to balance by inspection. We break it into smaller pieces. Also because everyone hates electrons, obviously. EOHEO. So what we'll do is we'll first write the two half reactions and balance everything, meaning like if there's one chromium on one side and two on the other, we balance it by inspection. Balance the oxygens using water. That'll give us some hydrogen imbalance since water has hydrogen. You balance those hydrogens using H+, so that's everyone hates. We then balance the electrons using electrons for each half reaction, and that balances that out. It usually involves multiplying an entire half reaction by some number. And then obviously it's only for if you're in basic conditions. We add OH minus for each. We can add some H plus. OH minus if basic is what it should say. Add OH minus for each if basic, add H plus if acidic. So let's go ahead and do an example. The question says, write a balanced ionic equation for the oxidation of iron 2 plus to iron 3 plus by dichromate in acid solution forming chromium 3 plus. Notice that this is already given to you in a net ionic form. They removed the spectator ions for you. If you were given a normal reaction, you'd start by removing those spectator ions since you don't need them. And let's go ahead and start. So the two half reactions are iron going 2 plus to 3 plus and dichromate going to chromium 3 plus. So it says first balance everything. We have one iron on each side, we're fine. Here we have two chromiums on this side and only one on this side, so we better put a 2 right there. That's the everything one, right? So there it is. We're now into oxygen. There's 7 oxygens here and none there. So let's add 7 water molecules for the O form, O part. See, I'm going to use the mnemonic. I get to the point where I don't need this thing anymore, but this is nice. So there's your waters. Then it's easy to go from this step to the hydrogen since it always creates this hydrogen imbalance. 14 hydrogens. So let's add 14H plus on the other side. What's next? Electrons. And if you see this, it looks like we're 12 plus on this side and 6 plus on this side. So how many E minuses should we add? 6 on this side, right? That gives us the same charge, 6 plus on each side. But we also have to do it for this one to balance it overall. If we are 6 electrons on the reactant side, we need to have 6 electrons on the product side up here to balance it. The only way to do that is to multiply the entire thing by 6. We can't just randomly add 6 electrons, so we're going to do it by the whole thing there. And so that's our 6 electrons, balances it on that side. It also keeps our iron balance. 6 irons there, 6 irons there. You should get the feeling that everything's kind of balanced at this point. So I think it's time to go ahead and add them. It is an acid solution, but we've already added our acid. So all we have to do, I believe, at this stage is combine it. Notice that this cancels 6 electrons, 6 electrons. You could take another line and you could write that out explicitly. These take so long anyhow that I just try to carefully combine it all as we do here. By the way, I learned the hard way that it is so much easier if you line up the two arrows of your half reaction and then work your way out like this. Thank you, Fred Vitale, for showing me that. And that will keep everything organized and make the adding much easier. If you come up with a different method, that's fine, but I think if you follow this exactly with the arrows lined up and then work your way towards the outside, you're better off. That cancels. We do have our 14H plus that just goes right down there. We do have the 6 irons that's going to go there. We do have the dichromate, which will go on the reactant side. And on the product, we have 6 irons, 2 chromiums, and 7 waters. This is canceled out. You should draw a line through it, giving us a total there. Now, amazingly enough, that should be a balanced chemical equation. You should verify it. Oh, let's take a chance and do oxygens. 7 oxygens on the reactant side, 7 oxygens on the product side. 2 chromiums on the reactant side, 2 chromiums on the product side. And if you continue, you'll see the whole thing is balanced. A couple of weird notes that tend to mess people up are that if you have an acid or a base, don't write it as a half reaction, write it completely. And if you have some spectator ions, you may find that you have to balance it manually as a final step. Don't be surprised if in the end you have to do a fairly small correction, and when we do the following examples, that will come up. Okay, so that is a little bit about balancing redox. In the following slides, we'll do lots of examples.